Welcome, everyone. Good morning, good afternoon, depending on where you're joining us from. I hope you're enjoying the day so far with this excellent program of speakers and discussions that have already started and will continue. We want to dive into this first panel session of today, which is looking at scaling private 5G, navigating spectrum, deployment blueprints, and ecosystem complexity. And as you can see, I have a very, very interesting panel with me today. And instead of saying a lot of words about each of them, I think they can do a much better job in introducing themselves than I do. So why don't we give everyone a bit of time to introduce themselves in the order of appearance on my screen. Joe, do you want to kick off?
Thanks, Leo. Yes, so my name is Joe Barrett. I'm the president of the Global Mobile Suppliers System. So we're representing the main suppliers in the industry, tracking 3GPP technologies, promoting 4G, 5G, and going into 6G, and various segments, including fixed wireless access, private mobile networks, which we are talking about today, and RedCap and other technologies. So we produce lots of reports, many that are free summaries, so that's what we're doing.
Excellent. Thank you very much. Stephen, do you want to go next?
Sure. Hi, I'm Stephen Leotis, president and co-founder of Mosa Networks. We're a US-based company designing, building, manufacturing simple, flexible, scalable, and cost-effective private 5G solutions. So we're solving connectivity challenges across many industry verticals here in the US and across the globe.
Thank you very much. Sam?
Hi, everyone. Nice to see you all and the audience. So I'm Sam Bao. I'm Deputy Head of China Mobile International UK. China Mobile International is a subsidiary of the China Mobile Group. We're responsible for the international business of the group, serving Chinese clients going abroad, as well as serving international businesses going to China. Thank you.
Excellent. That would be very interesting to hear more about. But before we dive into that, last but definitely not least, Murad, do you want to say a few words?
Sure, Leo. Thank you. Hi, my name is Murad Erkam. I'm a member of the product management team at Globalstar, a publicly traded LEO satellite constellation owner and a service provider globally. I actually represent the XCOM RAN by Globalstar business unit, which focuses on providing 5G-based private networking solutions, and looking forward to the discussions today.
Excellent. Thank you, everyone, for this brief round of introduction. I thought it would be interesting to begin by exploring where private 5G is gaining the most traction globally today. In other words, where are we today, and what's driving this growth, right? So if I turn to you, Joe, from what you said in your introduction, if you look at the work that you've been doing on tracking these global the global announcements of private cellular networks, which regions and industries are currently leading in private 5G adoption? And maybe more importantly, what factors are driving that momentum?
Okay, thanks, Leo. Yes, I mean, our September report really looks into, where the growth is coming from. I should quantify that. We are tracking networks, some that are public, some that are not public, from our members. So whether it's in certain countries or certain industries, and those private networks that are confidential or have limited information, but it allows us to track the growth there. And we're currently showing, over 1,800 networks over a 50,000 euro size. So we're not looking at small or test systems. And we're seeing those countries that, first of all, have made spectrum available for private mobile networks. So areas like Germany, Scandinavia, those regions. So Europe is the big driver. Around 36% of all the networks we are tracking are in Europe. North America, around 33% of networks, and Asia Pacific, 16%. But this doesn't include networks that are maybe using slicing from mobile network operators. So this is generally networks that are from non-mobile network operator support. So that's what we've been seeing. And then the factors that are driving this is definitely rooted in the enterprise needs. They want to be able to control their networks. They want to ensure performance, so that the service level agreements that they're getting from their provider meet their criteria, and of course security and flexibility beyond what maybe the public networks can offer. And some of those networks are across multiple sites, which makes it a lot easier for users to move between sites and maintain the same level of control, performance, and security.
Excellent, and we'll dive into some of these questions and some of these drivers in a bit later. But maybe if we double down on this geographical element first of all, that Joe opened up, right? If I turn to Sam, turning to you now, if you look at China, obviously has seen a significant private 5G deployments across sectors like ports and manufacturing. Now, I appreciate some of that might be more network slicing, virtual networks. But if you look at all of that, from your experience, what can the global industry team, from your approach, or learn from your approach, when it comes to private networks?
So in China, so this private 5G network obviously been taking off, and we look at the public available figures. China Mobile Group has in 2025, up to 2025, we've done like 64,000 private network, that including slicing as well. That's probably amount for 3/4 of the total private networks deployed in China. So what we see is it's a collective efforts from the regulator, from the MNOs, and from the industry together, ecosystems. So we are very keen work with ecosystems. The regulator for one of the examples, the regulator initiated we call Bloom Cup competition to encourage the industry come up with innovative 5G applications to show that it's a usage to the industry, to the different sectors. So that enables creating ecosystem that everybody be able to show that from the application vendor they can sell their applications, from the end users. For enterprise perspective, they can see the benefits of the 5G. 5G network for itself, for the enterprise, doesn't mean much. Only the application run on top of it, they will show the benefits of the 5G network. So this is probably one of the key elements in the whole 5G deployment, private 5G deployment in China.
Okay, very, very interesting. Now I want to go back to something that Sam has said, and also Joe has hinted to in the beginning, the importance of spectrum, right? And I guess if we go back to what Joe, what you have said, spectrum access is a critical enabler for private 5G, right? And regulatory approaches vary widely across these regions. So what spectrum options are available for private 5G today? I know you mentioned a few already, but it would be interesting to dive deeper into those. And how can enterprises and suppliers navigate throughout these regulatory differences to streamline their deployments then?
So what we've seen is probably the focus on the mid-band, the 3.3 to 3.8 gigahertz, often referred to as the C-band. So that has been a key area. I mean, that also includes, the US CBRS band as well, where we've seen interest there and, shared usage. But it's been interesting to see certain regulators within Germany, the UK, some of the European countries, partly in Scandinavia as well. They're actually allowing enterprise to license at very reasonable costs, sections of the spectrum. And that's encouraged then the growth in the market. It gives enterprise then the control over their spectrum and their whole network. We've also seen a little bit of interest around the 3.8 to 4.2 gigahertz in some countries, but obviously there are some competing technologies in the upper end of the C-band. And then there has also been some interest and one or two networks around the 26 gigahertz. Sometimes 28, it depends on obviously the region. Occasionally, we've got 1.8, 2.3 gig, so more the LTE bands, if you like, because we're seeing half of the networks that we're tracking are actually 4G LTE networks. The rest are predominantly 5G. So, the unlicensed has been interesting, especially in the US. But I think we'll see more interest now as more countries see the growth in the private mobile networks and the enterprise to manage their own networks.
Yes, I would certainly agree, and this is a very good point that you're making, Joe. There, one interesting element in this discussion, or one interesting company that we have obviously in this discussion is Globalstar, or XCOM, and the XCOM run by Globalstar division. So Murat, obviously with your expertise coming from the Globalstar background, how does your team at XCOM run by Globalstar then leverage the Globalstar allocated MSS spectrum assets to support enterprise private network deployments, particularly, I guess, in markets with complex or restrictive spectrum policies?
Thank you, Leo. Yes, Globalstar has received authorization to provide mobile satellite services in 120 plus countries globally. And the spectrum that was assigned to Globalstar was an ITU designated spectrum in L-band and S-band for Earth to space and space to Earth communication. The MSS spectrum has a component called ancillary terrestrial component in the United States, or complementary ground component in other countries, especially in Europe, to enable satellite providers with access to some of their spectrum assets for terrestrial service. So in Globalstar satellite constellation has been active since the early 2000s. And in 2016, Globalstar received its first regional authorization from FCC to use band 53, which is in the 2.483.5 gigahertz to 2.5 gigahertz range to provide terrestrial services. And with 3GPP standardization of this band, first as a 4G variant as part of Release 15 in 2018, and then as a 5G variant as part of Release 17 in 2020, it suddenly opened the doors because chip makers started implementing the support for the band, and end-user device manufacturers started building devices so that this band can be accessed terrestrially. And again, in the MSS world, it's like an FTD-like spectrum. There's an uplink and a downlink. Separate frequencies are being used, whereas in the terrestrial component, it's a TDD band. 11.5 megahertz, 2.5 has some advantages over the traditional 3.5 gigahertz because of the propagation characteristics. However, Globalstar's XCOM RAN division implemented a unique 5G based feature. Actually, it was also in 4G. That's called coordinated multipoints to increase the spectral efficiency. So even though the band is 10 megahertz from all practical purposes, the throughput that's enabled is equal to a 40 megahertz slice of spectrum. So XCOM RAN with its RAN product and its core partners and end user device ecosystem is able to provide this to enterprises and different verticals as a private network, 5G network alternative.
That's very interesting, and I think we'll come back to some of these points a bit later when we talk about the future of private networks, right? But now let's go back to Earth, if you want to put it like that, and talk about terrestrial infrastructure a bit more, because I want to bring in Stephen into this discussion. And as we heard from Joe already, when talking about spectrum, he mentioned CBRS in the United States. So I want to bring your expertise into this discussion. Obviously, CBRS has played a key role in accelerating private 5G adoption, particularly in the US. So from your work there, what lessons from CBRS can be applied to other markets looking to lower barriers to entry for private 5G?
Great, thanks, Leo. Yeah, it's excited to talk about this topic because I like to sum up CBRS to date as really a wild success, right? There's been tremendous growth in enterprise networks across the US due to CBRS adoption. And since FCC approval back in 2020, CBRS has really been a driving catalyst for both private LTE and now, of course, 5G to power industries from manufacturing, logistics, airports, to education and healthcare. And so, most people on the call probably know this, but CBRS is this special piece of the spectrum. It's 150 megahertz of mid-band spectrum that's nationally coordinated through what's called a SAS system or spectrum access system. And with this approach, this shared access model that was first brought on by the U.S. with this FCC approval in 2020, it's giving access to this reliable interference-free operation, free from these traditional barriers to entry, which historically had been getting some sort of license from one of the cellular providers, right, who owns this expensive license spectrum. And so what we're seeing now is enterprises can go from maybe they're running a Wi-Fi system for a while to being able to take advantage of these cellular capabilities without having to go through costly licensing or deployment models. And so really it's democratized the access to cellular connectivity. And so we see now indoor and outdoor deployments that provide better coverage, lower latency, built-in mobility, of course, with the cellular technology, and then SIM-based security, which is a much more secure way to connect devices to these networks, these wireless networks on different enterprises. And so, I think what we've seen is that this shared spectrum can be a model for accessing these private cellular technologies. And we see across other nations or other places globally making access to spectrum much simpler, and that's been really enabling enterprises to take advantage of these new cellular technologies that we're bringing with the private 5G.
Excellent, and I guess it helps enterprises expand private networks to other sites and replicate success makes all of that easier, right? As well, because that's I think the topic that I would like to discuss next with you guys is look at these deployment blueprints, expansion plans, and enterprise use cases. I know this sounds like a lot for the time we have left. But what I essentially want to do is look at how private 5G is being deployed and what makes these deployments scalable and effective. So if I go to you, Sam, first of all, going back to your experience from China and your learnings from China, what deployment models have worked best for supporting Chinese enterprises expanding globally with private 5G? And how do you ensure consistency across diverse regulatory and operational environments?
Oh, okay. So Leo, so we obviously serving many Chinese clients outside international markets. So many of them, especially those operates manufacturer bases, ports, mines. These companies typically requires 5G private networks. So we tend to provide them turnkey solution. So for across the globe, there's a different regulatory environment for the spectrum. So we depends on where we are. We work with local carriers to get a spectrum. We work with the application vendors for those vertical industries, which we have a rich experience and a rich the previous cases back in China. So we have those experiences to work with the enterprise to serve their end goal, which is the use those applications run on 5G to enhance their efficiency and the safety and the security, etc. So these are all achievable only because we've been doing this work in China for many different industries. In addition to that, the customers, our clients, when they doing business outside China, what their main goal are typically to focus on core business rather than like if they were in China, they probably would like to in contact with the application vendors themselves. Abroad, they trying to due to the unfamiliarity of the local market, they tend to they tend to request people like us to do a turnkey solution. So we had to adopt this approach, this request. So we build up a certain applications on top of the 5G network. We call like a PaaS platform as a service. Those platforms enables that different verticals be able to plug in their application into our platform to enable a unified 5G application package, so that the end user be able to select what application for them, and at the same time still maintain a single platform for easy to maintain the management. Yeah, this is our approach. We tend to create a overall solution for the end clients.
Now, when looking at these use cases that you described there, obviously enterprises face the challenge or opportunity to choose between different connectivity options. If you're talking about wireless connectivity, the two prominent examples are obviously private 5G and Wi-Fi. So, Murad, if I turn to you, what's your take on how should enterprises evaluate private 5G against traditional connectivity options like Wi-Fi or even wired networks to some extent when planning for deployments?
Yeah, excellent point, Leo. I think as Sam explained, ultimately the enterprises are focused on what they can do with the private network, and it's application focused. However, as you're pointing out in your question, the wireless connectivity becomes the highway that that connects everything, the application to the rest of the things that they want to be able to do, and it's not a one-size-fits-all situation. As you pointed out, Wi-Fi is an option that a lot of enterprises have utilized. But I believe, and I think Sam also pointed this out, in the industrial setting, private 5G has come out as a leader for the connectivity option for a lot of these businesses. And then once that decided, doesn't mean that they shouldn't use Wi-Fi for other communication purposes, maybe in the management administrative office, they can use Wi-Fi to be able to connect to a high throughput data network. But for in a port or in a manufacturing setting to connect automated mobile robots or all the other sensors, they would, if they decide to choose private 5G as their connectivity option, then they really have to consider spectrum access. I think, as Stephen pointed out, there are really good options like CBRS in the United States. However, again, one size doesn't fit all. There are certain areas where CBRS is unable to provide a deterministic access as a network provider. So then you have to go either with the mobile network operators that will allow you to access their spectrum, or depending on the country, certain spectrum options like N79, N78 in a lot of the Europe to be able to sign up a localized access to that. Or in Globalstar's case, we're offering globally available licensed deterministic spectrum as band 53. And again, a lot of options. It's a combination of different factors that come into play. And it all depends on what the local regulatory authority has approved. So once the spectrum option is clarified, then they have to look at the finances. And they need to do their return on investment analysis on how much additional business this implementation will bring to them, how long it will take for them to break even, and how much more growth they can support. So there's a lot of factors to consider, and it's not an easy answer. However, it is doable. As Sam pointed out, there is a lot of places where people have done it many, many times. And if you do it the right way, then there is light at the end of the tunnel.
That's a very good analogy. Now, let's assume an enterprise has deployed a private cellular network and wants to scale that, expand that further, and scale it across multiple sites or countries or even continents to some extent. Stephen, from your experience and supporting enterprises, when these enterprises begin expanding private 5G, what are the biggest barriers to replicating success, and how can network blueprints that you also have been working on help overcome them?
Yeah, it's a great question. We talk about this all the time, even at the beginning of projects with enterprises. And so generally when enterprises are starting out, there's one or two pilot sites. And what they're trying to do is they have some sort of business problem, connectivity problem, and they think 5G can solve that. And so you go in, each customer, they each have different needs and requirements, right? So you go in and solve that single site. And the challenges that we see, we've talked a lot about one of them, are around spectrum uniformity. So if you're doing a full domestic deployment, whatever country that is, we're doing a lot of work in the United States. So how can you use CBRS across the country reliably? The second item is, how do you replicate that initial technical success? So if a business has, let's say it's a warehousing business that has lots of sites across the country, how do you take that blueprint that you've created and duplicate it with the simplest of ease in each location? And then the last thing is, how do you maintain operational consistency across all of these sites? And so I'm just going to talk through a couple of these. So we've talked about spectrum quite a bit. And so we've talked about how, if you go globally, you need to look at the different frameworks that are available, different access rules, whether it's power or what kind of radio technology do I need? And so we're looking at, when you're designing a system for scalability, build a standard network architecture that's really spectrum flexible by design. So if you need to use CBRS in the United States, or pull in Ofcom spectrum or N79 other places, then you can do that with the same basic architecture on the back end. The second item on repeatability, outside of the unique RF characteristics, every location, whether it's indoor or outdoor, is going to have specific design requirements. This is the nature of physics, right? But you can have a network architecture, network stack, the core, the RAN, SIM management, security, and even the integration into the enterprise IoT or OT systems, and you can standardize that and really build a blueprint. And so, at MOSO, we are creating this idea of design or architect once and then deploy it everywhere. So what I mean by that is we're creating these technical templates and then operational procedures with our system integration partners so they can take these pilot systems and then really scale them across all their business locations. And one really key point there is once you get it deployed, you need the ability to manage it everywhere. So doing integration into an existing company's NOC or network operations center with their IT team is one option. You can do managed service provider type system where they're providing as a service, and again providing that visibility throughout the life cycle of the network is really important. So overcoming spectrum differences, reducing deployment friction, and then maintaining that replication across sites is what we're seeing is some of the things that need to be solved and optimized for private 5G.
Excellent. Now I know our time is limited, but before we jump into sort of concluding outlook at what's coming next for private cellular with the emergence of AI, both from a use case point of view, but also from an AI for networks point of view, I am just looking at the chat or the Ask the Speaker panel, and I realized that we don't have many questions yet to our speakers. So before we jump into that, please submit any kind of question that you have that we can then discuss in very brief. But with that, I want to close out by, as I said, discuss briefly and mention a few things of what you guys think will be next for private networks. So, Joe, why don't you set us off from what you've been seeing and what you're expecting? What will come next?
So I think that as we've been talking about, spectrum is going to be one of the key drivers, and the regulatory environment in different countries. We have a very large spectrum group supporting a lot of these release of spectrum and private mobile network requirements in many countries. And then I think from a technology point of view, although we're all talking about AI, I think RedCap is a clear driver at the moment, along with the non-terrestrial networks, as Murat has been talking about, because that will help provide a ubiquitous network, extending the mobile network operators domain and providing additional technology as well. And so I think those are the two key things that we'll see happening. And we're tracking that, and we also have a special interest group that is growing in membership now to help track and drive the adoption of RedCap.
Okay. Sam, would you agree with that, what Joe has said, or is there anything that you would want to add to that?
Yes, absolutely. I mean, the spectrum is definitely the key here. The latest sort of 6 gigahertz allocation has been discussed widely that in the US is prefer that to be allocated to the Wi-Fi community, where China wants to allocate it to mobile networks, where everybody else seems to be on the fence. So these sort of allocation definitely will impact the availability of the spectrum. I want to point to the other things. It's a ecosystem in terms of the 5G network itself. Stephen's company is building the cores, the core of the 5G network, which is a key piece. But as well as beside that is really the CPEs and chipsets, 5G chipsets and CPEs. These are not as widely available as a Wi-Fi, for example. So these will need an industry as a whole to create use cases, more use cases for these vendors and the manufacturers to bring their costs down to more affordable, for those devices. So by then, 5G deployment will be much more affordable and competitive alternatives.
That's a very good point. Murat, do you want to use that segue to jump in? What do you think is next? and will be
Well,
the next key challenge.
Yeah, I don't want to beat the spectrum drum anymore because I think we've done that. But I want to bring in another angle where emergence of AI, I think, is going to really drive the implementation of private networks, especially where physical manifestation of AI becomes critical. Like we've talked about in the manufacturing industrial spaces, where we would have automated systems, whether it's vehicles or robots that are moving, and an instantaneous decision with very low latency has to be made. That will require on-premises capabilities, what we used to call on the edge. Now we could be calling again different terminologies. We can assign different terminologies for it. Whether it's inference at the edge, whether it's processing at the edge, whether it's application running at the edge. But I think the private network and a dedicated capability, not only to provide the connectivity, but of compute, will be critical in enabling more private networks across different industries globally.
That's a very good point, Murad. Turning to Stephen, would you agree to that? Would you highlight something else?
Yeah, I'm glad Murat brought up AI, because I thought about this, and 5G and AI are really powerful combinations for redefining how enterprises are operating. AI really needs this reliable, low latency, and secure network foundation, and that's exactly what private 5G is bringing. So with this mobility native, deterministic, secure wireless fabric, whether you're deploying AI at the edge, to automate operations or real-time decision making, you can do it wirelessly with private 5G to create these different environments that are flexible and built for the agility for the modern enterprise. And so today we're building these networks to solve the more basic connectivity challenges. Could be enabling mobility or industrial IoT with these RedCap UEs and devices. But I think as companies adopt private 5G, they're going to find that they've kind of laid this digital foundation for the adoption of AI across their enterprise. So excited to see how AI gets integrated and really powered by these new wireless networks for enterprises, whatever their purpose in the industry verticals are.
Well, excellent. Thank you very much, Stephen, and thank you very much, everyone, for these very insightful discussions and points that you brought to this panel today. Thank you very much, Joe. Thank you very much, Stephen. Thank you very much, Sam, and thank you very much, Murat. I think we're back on time. Unfortunately, we don't have any much time left to discuss audience questions at this stage. But thank you very much for this very good discussion. Have a great rest of your day.
Thank you.
Thank you.